G'day Internet and welcome back to another SepTandy video. In this one we're going to go back to the Tandy 1000 and as we left it last time, it is stock standard. It has its 128k of RAM and a couple of disk drives, but we can do better. So this time round we get to the fun stuff and start throwing some upgrades at it. So the first couple of upgrades we're going to put in is an NEC V20 and a real-time clock. We'll go into the finer details in a second, but to put the real-time clock in, we need to get to a part of the motherboard which is covered with the disk drives, so we're going to have to strip this whole thing down again. So now we're going to put in the RTC. This simply goes into the main ROM socket and it goes into here. A quick thing I literally just discovered. The instructions for this say to put it in a Tandy 1000A into socket U51. I couldn't find U51, but I did find socket U9, which is what the instructions say to put it in for an original Tandy 1000. So this whole time I've been calling this a Tandy 1000A, I was wrong. I even titled the first part of this video series as Tandy 1000A, and I've got no idea where I got it in my head that this was an A model. It's not, it's an original Tandy 1000. Now that I've got that out of the way, let's drop this in. So, static strap, and it should just be a case of levering this out. Carefully. This goes into here. I might need to straighten the legs a little. Come on, get in there. Yep, we're all in. No legs that look like they're going to go sideways. Come on, line up. There we go. No, I'm going to have to straighten some legs. Right, and we're in, and we keep this aligned with the notch, same as it came out. And this, got a bit of a bent leg again, goes back into the socket here. And we're done. The next thing we're going to do is we're going to swap out the original 8086 for an NEC V20. Now, there's no real reason to do this other than the V20 does give a little bit of a speed boost. Most benchmarks put it around the 20 to 30% mark. And this is also just a straight swap out. So we should be able to pop our 8086 out. And drop straight in the V20, which has already got reasonably straight legs. Nice. And we're done. Right, I'll put the bulk of the machine back together and then we'll get on to the next couple of things. Right, the machine's all back together, so now we can start putting some expansion cards in. Now, the first one's going to be probably fairly obvious, and that's an XT to IDE. But I had to make a custom bracket for it. The reason is this. Now, you can get XT to IDEs with the compact flash reader built in. I didn't plan that well, and I ended up with the two separate devices. So I custom built and designed this 3D printed bracket which combines the two, but you do need a little bit of space in that direction for it to fit. And the compact flash is just running DOS 622, but there are some tricky things I had to do with the config sys and the memory arrangement, which we'll get to soon. Right, the next card to go in is nothing exciting at all. It is simply a serial card. Now, this is primarily so I can use a regular serial mouse. I do have the Color Computer Deluxe mouse, which supposedly does work with this out the joystick ports. But from my research, it basically says the compatibility is rather average, and you're much better off throwing in a serial card. This is nothing exciting at all. It's actually made by Computer Corporation of Australia. There you go. Right, so that can go into the next slot. And the final one to go in is this memory upgrade card that I got from Monotech in New Zealand. Links in the description below, which I believe is based on the low-tech design, but don't quote me on that. Now, the configuration of this is not as simple as it may seem. Let me explain. Before we get started, I just want to be clear on one thing. I kind of know the basics about DOS memory management, but I was a kid when my father was messing around with this kind of stuff on a 286, and so I've had to have a very steep learning curve on getting this all working on the Tandy 1000. I do need to give two shout outs though. The first one is to Adrian Black, who provided me the tools and a way forward with what I'm about to show you. And the other one is to my mate Randall, who helped me kind of get my head around it. I had gotten to the point after about a week of mostly getting there, and it wasn't until he threw a second set of eyes on this I kind of went, oh, right, now I know what you're talking about. So, let's get started. Here we have, I'm just going to draw out, here is our memory, okay? We've got 0 kilobytes down here, and we'll make it 1 meg up here. And somewhere in here is our magical 640K mark, okay? Now, the Tandy 1000 comes with 128K of on board, so that's here, 128K on board, okay? But it's not quite that. There is actually 16K of video RAM here, VRAM, and it's 16K. And what it does is it actually kind of steals this, right? And maps it up further. It's not important for the base 640, but it will become important later on, okay? And that's how the basic RAM works. Now, we want to add more RAM to this system. Now, it would seem logical that you would take a 512K expansion and you would stick it in. But where does it go? In a PC Junior, far as I'm aware, now I don't own a PC Junior, but from my understanding this is the way it works, is it simply slots in here. But unfortunately that leaves this 16K kind of floating in the middle, and there is a bunch of utilities that you can map this further up, but from what I can gather the compatibility isn't fantastic. What the Tandy 1000 does is a little bit smarter. So let's just take this out. We'll leave it for there. What it does is it actually shuffles all of this up to the end here, okay, and then including the VRAM. So we've still got our 16K VRAM here, V, and you actually put the 512K into this space here. And so that obviously gives you all of this space to play with, and that's a lot more useful. But when I set this up, load up DOS and run check disk, by the time DOS loads and everything else, you end up with and I can't remember off the top of my head, but it was 580 something K of free RAM, free memory. Now, if you've ever mucked around with early DOS stuff, you know that isn't great. But we have all of this that in theory we can play with, but it's a little bit more difficult on an XT class machine. So how are we going to use this to increase our free RAM? Well, let me wipe the board and draw it out again, and I'll show you how this works. Okay, here is our 640 to 1 meg. These little marks will make sense in a second, and so will the 960K mark. Now, it's not just a case of writing stuff to this area of memory, because there's things that already live here, and one of them, in my case, is the XT to IDE. Okay, it has a 32K boot ROM that needs to sit in RAM somewhere. Now on mine there's a series of dip switches which allows you to place that 32K somewhere, and that is C800, D1000 and D800. And where this actually maps out to is 800K, 832K and 864K. So now it's a case of where do we want to put this? Do we want to put it high and then use a lower chunk of RAM? Or do we want to push it low and use an upper chunk of RAM? And we're going to go for the putting it in lower. Now I'm just going to cheat for a second. And it is 1, 2, 3. Okay. So we're going to put it here. Now, I've put this mark here for a reason. On the Monotech, there is 5 dip switches, and they allow us to turn on and off various chunks of memory. And this is these 5 marks, well, 1, 2, 3, 4, 5 chunks here. And this happens to be 832. So where we're going to put our XT to IDE BIOS is actually underneath there. So XTIDE, and it's going to sit there, and that's 32K. These are all 64K chunks, by the way. So you could probably think, well, why don't I just put it here? Well, for starters, because this is sitting here, I can't use that RAM block on here because it will wipe out the XT to IDE. Now, you're probably then thinking, well, why don't I put it there and use these 3? Well, remember the CGA RAM that I mentioned before? Well, it actually sits, and I've got to try and remember now, it actually sits here. Okay, and it's actually the CGA RAM space, but we'll call it TGA. Okay. So all of a sudden, we can't use this one because it will wipe out the video RAM. And so we end up with this bit of a mess. So even if I move this one to here, we'd still only be able to use this individual block because there's something here, or this individual block, and these are only 640K blocks. So this RAM expansion doesn't actually go up to a meg, it goes up to 960K, and that's why that's marked. So we're actually going to put our UMB here. And for those that are interested, the actual address range is, and I've got to try and remember, is D1000 through to F1000. Okay. Now, for interest's sake, the system ROM actually sits up here somewhere, and I think it's F, I think, maybe? I can't quite remember. Or F800, it's one of the two. Anyway, it sits above the 960 mark, so that's fine. So we're going to put our UMB in this 128K here. And, okay, God. And if you go back to here, you will see that I've got those 2 RAM blocks switched on the Monotech board. So that's all the theory and mapping it out. How do we actually put this into practice through software within DOS? Well, this is where the tools that Adrian sent me come into play. So let's take a look at the config sys file and we can get a better idea of how to implement all of this. So here we have the config sys file that Adrian sent me, plus I've changed a couple of things to match the memory map in this particular Tandy 1000 versus his EX model. Now we start off with files and buffers, there's nothing particularly exciting about that. But we then move down to this device driver called clearmem.sys. And for this, it's device equals clearmem.sys d1000 2000. And this actually threw me initially, because I'm like, 2000 isn't a memory address, and it's not. What it's referring to is to clear out 2 chunks of RAM, 2 memory blocks, which in this case equals 128K. And this is basically a safety mechanism to make sure that there's nothing written to RAM before we load our upper memory block device driver. And that's the next thing. Device equals use !umbs.sys, which is our upper memory block device driver. And we're putting this into D1000 to F1000, which, as explained before, is our 128K spare chunk of RAM in the upper memory area. We then load another device driver called DOSMax. Now, the switches on the end here are essentially just some debug information on boot that tells you, yes, I loaded fine, and no, I didn't. And it then also utilizes shellmax, which we'll get to in a second. Now, use !umbs.sys is completely compatible with DOS 622's command to load DOS high. So that's really handy as well and gets rid of DOS out of the lower memory. So then for the shell command, like I said, we load in DOSMax's shellmax.com. And what this does is this is able, between it and DOSMax, to load a whole bunch of extra stuff, not just DOS, into the upper memory block. Things like, as an example, mouse driver. So without the mouse driver loaded, I ended up with 620 odd K of free RAM according to CheckDisk. Loading the mouse driver, Cute Mouse in this case, I still ended up with 620 odd K of free RAM because shellmax, between shellmax and DOSMax, it's smart enough to go, oh, that's a mouse driver, and load it straight into the upper memory block automatically, which is really handy and frees up even more lower RAM. Right, with the explanation on how to actually set this thing up and mess around with config sys and a few tools, this can now go into the final slot. And we're done. We are completely upgraded. We now have a hard drive. I'm using a 256 meg CF if you're interested. We've added serials so we can use a regular mouse, and we've given the memory a substantial boost, thrown in a NEC V20 and a real-time clock. Now, don't get me wrong, the real-time clock is probably the least necessary of all these upgrades, but it's nice to have. Well, that's everything installed, so let's power it up. And you'll see DOS starting, and this is all the upper memory block stuff, and DOSMax launching, and shellmax coming in, and the RTC kicking in. And if I go date, it's today's date, and it's Y2K compatible. And now we have a nicely pimped out Tandy 1000. Now, I have to be brutally honest with you. XT class machines I tend to struggle with, and it's primarily the CGA graphics. There's just something about that magenta and cyan that just doesn't do it for me. Now, I know a lot of people do like that, and there's a certain degree of nostalgia around it, but for me, my first PC as a kid had at least EGA graphics, so CGA is something I've always struggled with. But the Tandy 1000 fixes that. between its Tandy graphics and sound, it really lifts the bar of the quality of games that you can play on this. And for me, this era of gaming will always stretch to the Sierra adventure games. They're my favourite, they always will be. So King's Quest, Space Quest, Leisure Suit Larry, all those games. And this is just now a perfect machine to play them on. So I hope you enjoyed the video. Click like, subscribe, all that kind of stuff. If you'd like to support the channel, you can now find me on Patreon, link in the description. And don't forget to check out all the other SepTandy videos. And I've been compiling a playlist of those, again, link in the description, as they've gone live. So thank you very much, and I'll see you in the next one.